In this video, we are going to calculate the variance of a data set. You have found the following ages in years of 4 tigers. The tigers are randomly selected from 31 tigers at your local zoo. So the ages were 22, 13, 18, 16. Based on your sample, this is going to be a big difference in finding this, what is the average age of the tigers? And then what is the estimated variance of the ages? So sample means I'm only taking a little portion of the tigers out of the 31 tigers. If I was talking about population, I would be taking all 31 tigers. So I will show you the difference of which for the population and for the obviously for our sample variance here for today. But then I will also show you how to calculate the population variance because you'll need that also for today. Now, the average, first off, is finding the mean, and that happens to be our first step anyway in finding our variance. So step number 1 is to find that mean. Now, for mean for a population, remember, for a population, we use the mu. It's the Greek letter, the mu. But for a sample, we're going to just take x and put a line over it. So the sample mean is we take the 22 plus the 13 and we'll add the 18 and the 16, and we're going to divide that by the amount of numbers that we have. So we have here 69 divided by 4, which is 17.25. So that's our sample mean. So we are going to take that sample mean in step number 2, and we're going to subtract it from every age of our tigers. So we're going to take each age, we're going to subtract it by our sample mean, and then we're going to square that value, because we don't want negatives, remember. So we're going to have 22 minus 17.25. We're going to have 13 minus 17.25, 18 minus 17.25, and 16 minus 17.25. We're going to take those values, find our answers. So the first one ends up being 4.75. We're going to square that value and get 22.56. We'll round that to the nearest hundredth there. 13 minus 17.25, we get negative 4.25. Square that value, and we end up getting 18.06. 18 minus 17.25 ends up being 0.75. Square that value, and we get 0.56. And finally, 16 minus 17.25 is negative 1.25. Squaring that value, we get 1.56. Our last step is to take the sum of all those. So the sum, step number 3, is the sum of all our ages minus the mean, the sample mean squared. So we're going to add the 22.56, 18.06, the 0.56, and the 1.56, and we're going to get the sum of all that, which is 42.74. Okay, so there's our sum. So now is the part where we're going to find our variance. Now, since we need our sample variance, right? We're taking the variance of a sample of our tigers. All right, we are going to take that sum, okay, what we just found of our sample, and we are going to divide it not by the number of tigers that we have, because remember, we're dealing with a sample here. We're going to take it by, we're going to divide it by n minus 1, one less of those tigers, okay? Because remember, we're estimating here. So we're going to take that 42.74, and we're going to divide it by 4, because there was 4 tigers, minus 1, which is 42.74 divided by 3. We get that answer to be 14.2. Now, if this was a population, for a population, so remember this is for a sample variance, for a population variance, we would end up, for a population, I'll just abbreviate variance, that would be the sum of x minus x, sum squared over n. So that you would not subtract 1, you would use 4 and find that answer. So we're going to type our answer in here. Our average was 17.3 because we had to divide, and 14.2, we have to round to the nearest 10th.